have a question on the homework.
Yeah.
On number 6, I'm going to bring up the question again. It's asking us to do a problem that portrays multiplication as more than repeated addition. So is it just wanting something more than just like 2 times 8 or 2 times 4 equals 8 because it's the same number repeating? Is that what you're kind of asking on that one?
Well, we talked about, it's referring to the part that we talked about where repeated addition is something that we do, and we can answer it using multiplication. But sometimes there is a point where the repeated addition idea for multiplication breaks down, and it's looking at something like when you get to multiplying fractions. Okay, so you multiply fractions, you can't like do repeated addition because there's not more times that a fraction is done. It's only done part of a time. So
gotcha. Okay.
You add 3 4 times, you can't like add 3 a half a time or something like that.
Okay, thank you.
Good. Any other questions? You guys doing the test okay? Okay, just plugging along. Well, good. Let's go ahead and take attendance, and then we'll get started with our today's lesson. We're doing the third part of Unit 3 on multiplication. So oh, we lost somebody. For a second. Maybe they'll pop back in. Okay. All right. So yes, it was Mo. Okay. We're going to go ahead and turn to a PowerPoint. We're talking about automaticity for multiplication. And so we've talked about operation meaning last time. What does multiplication mean? So I'd say like multiplication, as a reminder, means that you are taking groups of objects. So I have 5 times 3 is 5 groups of 3 objects in each group. Okay. And it's a total, so you're finding the total amount of objects or things that you want to count. It could be set objects like marbles or dice or something. They could be area objects, or counting like square feet, or you can even count inches and so on. But we want to be able to multiply large numbers. Okay? And large numbers have many digits. And in order to do that, we break the numbers down into single digit times single digit facts. Okay, so that's how you multiply large digits. And you also multiply them using powers of 10. So we're going to build up to the standard algorithm by doing that. But first, we're going to cover today how to multiply single digit facts. One number times one number. Okay, so I'm going to share screen with my iPad. Okay, we're going to play this PowerPoint. All right, so we want automaticity for multiplication. Okay, that's what it's called when you are automatic with computing multiplication facts. And I'm going to put this up here. Gonna run into some room issues here. Let's go like that. Hopefully that'll work. No, we're gonna have to go sideways. So I'm running out of room here. Or maybe it doesn't do sideways. Hold on. Let me unshare and share again. Just getting my iPad screen to look okay. This is actually kind of small too. Okay. Yeah, so it's just going to do this automatically. So we'll go to speaker view, active speaker view. No. What if we go on this side? Good idea. Okay. We're trying to, because what we're going to have here is we're going to have some, use all the screen for our multiplication table. Let's see how we go. Oops. All right. So for multiplication, we need to learn and teach our students 169 facts. Oh gosh, come on now. Being crazy. Okay, sorry about that. Hold on, folks. Let's go and play there. Okay, so what we have are where you need to learn 169 facts. So I think in Utah, they really focus on going up to 12 tables. So I've diagrammed all of the facts here. Now, for some people watching the video, they'll have one column cut off here, but hopefully you guys can see that okay. All right, so how do we do that? Well, we don't want to do, well, I don't know. Maybe I can have you guys talk for a second and share out how you guys learned all of these. Does anybody have any memories from elementary school?
We did the timetables charts. So they went from like, we would have our ones one week and then our twos the next week. And they would just time us on how fast we can complete them.
Okay. What do you think about, how do you feel about that? As a teacher,
It
as
gives
a
me
student?
a lot of anxiety. I don't think it's very productive.
Yeah, it gives you anxiety.
I didn't like doing the time test. It was like super stressful, and then you forget and start messing up. The way that I remembered was like the zeros, the ones, and the 5s and 10s. And then I would, if it was like 6 times 4, I would do 4 times 5 and then add 6 and then add 7. Like it was just easier for my brain to work it that way.
Yeah, and those are the kinds of strategies that they talk about in the Singapore math book in 3A. And you'll go over that in the homework, and we'll talk about that today in class as well. There are strategies to solve these and easier than just memorizing. Okay? But it's important, and they talk about this in the book, about why they need to be memorized. Okay? And so the authors talk about freeing up working memory, learning how to do more complicated math, empowerment. There's several examples about why we need to do this. A lot of people are averse to memorizing the facts. So, but hopefully the book will help you understand little bit more about how it can help you to know these facts. But yeah, as you introduce them, it's going to become a process, just like Camille described. We'll use thinking strategies to find them, but we want them to become automatic, okay? Where that they've done it enough times that they know what the answer already is. And that's one of the reasons why people have tried to do this with time tests, but the timing element is tricky because it gives people anxiety and they forget everything. Okay. Any other thoughts? How did you guys learn these when you were in elementary school?
With the 9 times, you can do them on your hand.
Okay,
Like,
we'll get to that when we get to talk about
That's
nines.
that's
Okay.
right.
And I'll have you share out then. Is that okay? But like even in general, what did you guys do? You have to learn multiplication facts. How did you guys do it?
It's just a lot of repetition, flashcards, just going over it over and over.
Mm-hmm. Yeah, a lot of repetition. Okay. Well, okay, so I seem to have the same kind of people contributing. So when I ask some more questions later on, let's have other people contribute as well. So I hope that people are focusing on the class and not like trying to multitask things. But anyway, moving on. We do need to talk about each of the groups here, and I call them tables, like your zeros and your ones tables or your fives tables. Okay. So we're going to think about how each set of facts are memorized, okay? And we are going to start with the zeros. So anything that we have multiplying by 0 on our column here, that's highlighted in green, and our row, top row, that's first column and top row, are all multiplied by 0. Okay? And the zero product rule says that whenever one or both numbers are 0 multiplying, then the answer is 0. Okay, so I use that, I write that example up here at the top of the slide. Okay. And moving on from there, so zeros are, they need to be taught, shown to the kids, and once you know that like 0 times 4 is, or 4 times 0 is 4 groups of 0, or 0 groups of 4, you have like nothing there. It's pretty trivial, so that's why you have to kind of show them. They can get it. So all of those facts can be taken care of with the zero product rule. Next, we're going to do the multiplicative identity property. So if you have 4 times 1 or 1 times 4, anything times 1 is itself. Okay? There's a kind of a rule like that too. Anything times 1 is itself. Okay, so you can think about that using the multiplicative identity. So we're eliminating sets of facts by using rules. And so there's several rules that can eliminate most of the facts here that make it a little bit easier to memorize. Now the times 2, so 2 times something or something times 2, we use doubles from addition facts. Okay? The students have worked with addition and they know what doubles are. Okay? It's important to describe that these are doubles when you add 2 4s together. Okay, that's doubles. Okay, a lot of students get this confused. But when I multiply 2 numbers that are the same together, that's called squaring. So these are called the squares. Square facts. So doubles are adding the same thing together. Squaring is multiplying the same thing together because it's derived from the area of a square. Okay, if you have a square, you want to find the area. There's your side, and there's another side. You multiply them. Area is equal to side times side, or side squared. Okay? So we call them the square numbers. And in the future, 8th graders will learn about square roots, which is the opposite of squaring. Okay? So that's why we call it square facts. So anything from doubles times 2 is going to be your 2. You can do 2 tables. You can just take the number and add it to itself. So those aren't too bad for the students to learn. Now what we're going to do is we're going to eliminate most of them, and you can do this before you talk about 1s and 0s and 2s. Okay? The commutative property says that 4 times 5 is the same as 5 times 4. Anything, doesn't matter the order that you multiply things in. And so I've separated the last set of groups here into 2 parts. Well, there's 3, kind of with your square numbers. But you don't have to memorize, and this will work for the other ones too. You don't have to memorize everything. You can usually get a fact from the commutative property, where you switch them into a group that you know. Let's say that you like to count by 5s, for our example. Okay? But you're doing 4 times 5. But I want to do 5 groups of 4, and I like to count by 5s. 5, 10, 15, 20. And so you can switch the numbers 4 times 5 instead of counting 4 groups of, so you can do 5 groups of 4 and 4 groups of 5. Sorry about that. Yeah, so you like to do, let me start that over. 5 groups of 4 is what you like to do. No, sorry, 4 groups of 5 is what you like to do. And then, but you have the 5 times 4. But you know that they're equal in value. So you can count by 5s and get to know what 4 groups of 5 are instead of, and what 5 groups of 4 are instead of 4 groups of 5. Okay. So they can help you go faster. So we can eliminate the whole set of them. Okay. All right, so now we're down to this many, and then we can talk about multiplying by 10, which you can do with the other ones as well. I've already eliminated. You multiply by 10, you want to consider place value. We're going to talk about multiplying by 10 because it's special in the multiplication algorithm. We'll talk about that later, but about what it means to like add a 0 or whatever. Okay. For now, we're going to consider that 4 times 10 is something like 4 10s. I have 4 10s that I'm going to find the total of, and that would be 40. So you can add a 0, but we'll talk about in more detail in another day what that would mean. So we have eliminated this set of facts. We're going to have these 3. So we want to think about more ways to eliminate facts, kind of using general properties or approaches. And when you multiply by 3, it's 1 more than the double. Okay, 1 more than the double. So what we're going to do is we're going to multiply by 2. So if I do 3 times 4, I have 2 groups of 4 and 1 group of 4. The double is 2 groups of 4. And I'm adding 1 group of 4 on top of that. So it becomes 8 times 4, or 8 plus 4. You can do this using the distributive property. Notice that the 4 is being multiplying the 2 and the 1. Okay, with my double plus 1 kind of idea. Okay. In the slide presentation, we're going to do the mathematics about proving why they work. After we go through the slides, we're going to go back and talk about our rules in a more mental math approach. Okay. So this is why you can do 1 more than the double. You split the 3 up into 2 groups and 1 group. So you do 2 groups of 4 and 1 group of 4. You add those together. When you know that the 3's table is 1 more than the double, 1 group more than the double, then you can eliminate those facts. Any questions so far? Guys excited? Yeah. Now 4s. Approaches to 4s tables, the one in the book, they call it doubling the double. Okay, so you split your 4 into 2 times 2. If I wanted to do 4 times 6, okay, I can do 2 times 2 times 6, which means I distribute the 6 to these sum. Okay, remember distribution is by multiplication over addition, or the two basic operations there. And I have 2 plus 6 times 6 plus 2 times 6. So doubling the double means that I'm going to add on the same number, the 12 and the 12 here, and it's easy to do the same process a couple of times. Okay, and I get to 24. All of these can be done by doubling the double. Okay, so what I did was I showed you how to do that one. 4 times 8. I can do 2 times 8, 16, and add 16 again to get to 32. Multiplying by 5 is half of multiplying by 10. Okay. You can count by 5s. A lot of students do repeated addition type ideas. You can do lists and counts and chants in your classroom, and those are good approaches. It's also good to have an idea of what else to do, because this reminds me of when my second daughter was learning 8s, or another fact, and I tried to think about doubling the double, and I tried to think about multiplying by something, by 5 and adding 1, or things like that. And one of them clicked with her, and then she's able to do the 8 facts. So we'll get to that in a minute. But knowing a bunch of ways about how to multiply numbers will help you with students that don't get one way or the other, and they can try them out. So you have like a tool belt, a repertoire of how to memorize these and how to calculate the answer, really. So which leads to memorization. So we have 5s. You can do count by 5s, or you can do multiply by 10 and then half it. So we're going to calculate 5 times 7. And I'm changing my 5 into half times 10 times 7. Now I'm going to use the associative property to change it to half times the 10 times 7, and then half times 70, which gives me 35. Okay. So that's how that one works. Multiplying by 11 is one group more than multiplying by 10. So essentially what I'm doing mathematically, why this would work, is that I'm taking my 11 and splitting it up into 10 and 1. Okay? So I can use the distributive property on the front to do 6 times 10, 6 times 1. 6 times 10 is 60, times 1, plus the one group of 6 is 66. Okay? So what I did in these ones, I kind of like also looked at the digits and I'm like, well, I'll just change the 1s to 6s. So you can do that too. But this is mathematically why it works. The mental math is good to know that we can just break up numbers, multiply the partial products. Okay? So we call them partial products. That's what this is right here. I'm taking the 6 times the 10 and 6 times 1. Those are products, but they're not the whole answer. Okay, because I have 60 and 6, and then when I get the whole product of 6 times 11, that's 66. But I have intermediary steps to get there. This is kind of an introduction as well to the multiplication algorithm. And we find the answer to a multiplication problem using steps, partial products. Okay, we're good on 11s. Number 12, you can multiply anything, so not just like the ones that we are left, but you can do any 12 by doing one double more than 10. Okay, so it's taking my 12 and splitting it to 10 and 2. Partial products are 6 times 10 and 6 times 2. 60 and 12 makes 72. So that's similar to 11s and similar to a couple other ideas. 12s come in handy a lot of times. 9s. 9s can also be thought of in like the book is multiplying by 10, but then you do one group less. Okay? So 6 times 9 is the same as 6 times 10 minus 1. So I'm taking that 9 and I'm substituting in 10 minus 1. Using the distributive property, I can do 6 times 10 and 6 times 1. This is the distributive property of multiplication over subtraction. Okay? We have 6 times 10 and 6 times 1. We get 60 minus 6, and we get 54. Another way to use that is like 8 times 9 is 8 times 10, subtract 8. So you get 80 minus 8, you get 72. So that's the shorter way. And we'll go over the short ways after this to help quiz you. See how much you remembered from this PowerPoint. Okay, that's multiplying by 9. So notice that I'm grouping my facts into some processes, conceptual, okay, because we're using differences of 1, adding 1, subtracting 1, doubling, okay? And I've eliminated all but these 6. So with several ideas, you can eliminate all facts but 6. Now these ones, there wasn't any real rule with them. So you have these 6 here. And it's 6 times 6, 6 times 7, 7 times 7, 6 times 8, 7 times 8, and 8 times 8. So these are the hardest facts to memorize because we have kind of some ideas of what to do with the other ones. But these ones, they don't have any really general ideas, but you can use the distributive property, associative property, commutative property. Well, we already got that down. Okay, you can use associative property and distributive property to help make them easier. And like breaking up the numbers. I'll do an example, but then we'll kind of go back to it. So with 6 times 6, I can do 6 times, break up my 6 into 3 times 2. Okay. Now using the associative property, I can know that that's the same as 6 times 3 times 2. Okay. So I'm going to use a double in here. I use the 2 to make a double because I'm going to do 18 times 2, which is my double. And that gives me 36. So those are the kinds of things that we can do. We can split things up into sums as well. Let's see. 7 times 7. 7 times 7, I'm going to split my 7 up into sums. 7 times 5 plus 2. Because we know that times 5 is easy because of our counting or multiplying by 10 divided by 2. 7 times 5 plus 7 times 2. We get 35 plus 14, which gives us 49. Okay, so we can do that with breaking up one of the factors into a sum and use the distributive property because they distributed the 7 to the 5 and the 2. Okay, so those are the ideas of mental math of how to calculate these ones which don't follow any real guidelines here. Okay, hold on a second. Okay, now that's how we, that's our slideshow, and I'm going to post this slideshow up on Canvas so you can see and go back through how that works.
I'm curious, do the kids, are they able to compute all of that in their heads, or is it easier just to do on paper doing it those ways?
Well, some will be doing on paper. They can start by doing that, but they'll do more practice, and you spend a lot of time with multiplication in like the 3rd grade, maybe even 2nd grade. I think it's 3rd. And they will, in 4th, there's a lot in 4th, you'll practice them too. But yeah, they can do this in their head. You'll have good curricula that will guide you to help them do that, as far as I've seen from the various school districts. So I haven't seen a lot, but I know what my kids have done, and I've seen a couple of things from that, their classrooms and their teachers, as they have all gone through the 3rd grade. So.
Okay, thank you.
Yeah, and some of them, like some of my kids, were able to get the facts down easier than others. But what's great is that, like my 2nd daughter, she was able to use the strategies more so than just having it come to her head. So you'll get the wide variety of students. So great question. Okay, so there's somebody else that has. Okay, no. Okay, there's one person that I don't have on my paper here because I have 14 on my paper. Oh yeah, I'm good. We have 14. Anyway, we're moving on to seeing how well you guys kind of can heard that or process that. It's okay if you don't remember everything because I went through it kind of fast. And we're going to go ahead and give some examples, and we'll talk about as a class how we could multiply them. Okay, so I'm going to go ahead and share with my iPad. Okay, so what we have is, let's go ahead and have people, let's see. So we call this the 2.3, it's automaticity. And multiplication. All right. I'm just going to kind of go through some of the tables that we have here. How did we memorize the zeros table? Okay. Anything with the zero, multiply zero, whether it be 0 times something or something times 0. How do we memorize those?
It will be groups of zeros. So
Okay.
it'll always be 0.
Yeah. And what is the rule that's known in the math ed community or among teachers that says this? What's the name of that rule? Or property? It's called property, really.
It's the zero property rule.
Right. Zero, close, zero product. Property. Rule. Those are kind of interchangeable. They're synonyms. I think people use the word rule more. Because I'm describing the rule with 2 adjectives or 2 things, I put a hyphen, so that's why it's hyphenated. The zero product rule. All right, that's what says that anything times 0 is 0. Okay. Okay, this one's going to be a little bit more formal or informal than what was in the PowerPoint. The PowerPoint was more formal as rules proving, mathematics proving why they work. Here we're going to just go informal, mental math type approach. So if you have anything times 0, it's 0. And the zero product property is the reason. But the kind of the saying that we use is anything times 0 is 0. Okay. And feel free to share out as we talk about these of other things that that you've learned or tricks or I don't know. Gotta be careful with tricks in math because sometimes they'll do the trick but they don't know why it works. Okay. So, all right. So that's the zeros. They're pretty straightforward. Students just need to be shown it and they'd like to talk about like, well, this is what we do as a convention. This is how we all talk about it in later math. So. Okay, what can I do to know the ones tables?
The identity property.
Right.
So that it's always one group of itself. So it's always the one group.
Yeah, so it's the multiplicative identity. Remember, identity is when you're operating on the number, but it does not change the value. Okay, so I'm going to multiply by 1. Okay. The kind of the code that people say, oh, go ahead. Okay, so the quote that people say is anything times 1 is itself. Okay, so that's a good way to remember that one. Okay, the next one's the twos tables. Okay, how do we know what 2 times something is or anything times 2? How do we know what that is?
Isn't it the doubles?
Right.
It's just double itself.
Doubles, like you're going to add it to itself. Okay. So I'm going to do some examples here. 2 times 5. Okay, so I'm going to calculate 2 times 5. Okay, so how does this work with what we just talked about? Somebody kind of just say like 2 times 5. How does that work with doubles?
It'd be 5 plus 5 would be the double combination.
Right. And you know that that answer is 10. Good. So that's the doubles. Next is tens. Next we went to tens tables. Okay. What do we do with tens if I have I do like 3 times 10 or 10 times 3? How do I find the answer?
You add a 0 to the number.
Yep, you can add a 0. Good. Okay, are some people having some screen problems? Or are you guys good now? Okay, so for tens tables, you think of place value. That's where we're going to go for right now. 3 tens is equal to 30. You can add a 0 onto it, but when we get to decimals and all of that, it'll be trickier. We'll get to that. Okay. Next we did threes. Okay, we need to do 3 times something, not just 10 as I did in the other one. If I wanted to do 8 times 3. Okay. Anything times 3 will work with this. How did we calculate our threes?
Doubles plus 1.
Right. We call this the doubles plus 1 or doubles plus 1 group. Okay. 8 times 3. So I'm going to double 8. Oops. Okay. I'm going to add on another 8 to that. We call it plus 1. It's plus 1 group of 8, another group of 8. Okay. So that's how the doubles plus 1 works. What happens if I wanted to do 3 times 7? Can someone guide me through that one?
So you would take 7 times 2 or 7 plus 7, which equals 15.
Okay, 7 times 2 or 7 plus 7, right? Because those are going to be interchangeable. Okay. And you get 14. Good.
And then you just add another 7 to 14.
Good. Right. So some people might count on from 14 to get up to from that 7 on their fingers, and that's okay. And the more they practice it, the more automatic they'll get to it, to where they can associate this 3 times 7 to 21. All right, so we have the threes table. Let's do the fours tables. Okay. How do we calculate anything times 4 or 4 times anything?
Double the double.
Let's do, yes, double the double. So if we wanted to do example of 4 times 9, that's pretty tricky. That's 4 times, there's better ways to do the 9s. So let me think about 4 times 6. Let's try 6. Okay. So we're going to double the double. Okay. So double 6 is 12. Okay. This could be like, these types of things could be talked about in a number talk. I don't know if you know what a number talk is, where you gather the class and You say, okay, how many ways can we solve 4 times 6? And you write them on the board and so on. We'll talk more about number talks in 2015. But double the 6 is 12. Then you want to double your 12. Okay, so double 12 is 24. So we know that 4 times 6 is 24. Let's do another example. 4 times 4. Okay, can somebody guide me through that one? Who hasn't spoken yet? Doubling the double.
So you could do 4 times 2 is 6. And then 4 times 2 again is 6. Or 8, I'm sorry.
Yeah, and then what would you do after that?
Then I just did it again. So 4 times 2 again.
Oh,
Then you add it 2. And then 8 plus 8 is 16.
oh, well, let's write it better than that. These are what we call equation stack. And we're copying all of her thoughts into sets of equations there. Okay, great. Yeah, 4's tables, doubling the double. So that makes it a lot easier. Students can handle that a lot better than counting 4 sets. So you can do like 4, 6, 12, 4, 8, 12, and 16. You can do the list like that. Okay? But sometimes it gets tricky because they'll have to keep counting on from 8 and 12 and so on. So doubling the double is a faster way and it's a little bit more efficient. But sometimes students stick with like counting the list, you know, listing out the multiples of 4. Some people like to double, some people like to do other things. Let's see. Okay, 5s. Okay, we can have like a couple of ideas here. What do you guys think? How can you get to the 5s tables? Calculate anything times 5. Like 4 times 5, or 5 times 4. Actually, we did that one in the PowerPoint. Let's see. Let's do 6 times 5.
You can just count up in 5s, groups of 5s, 6 times.
Right. So you have 10 fingers, and so if we're just sticking with single-digit facts, and we'll expand to like the 11s and 12s, you can easily count by 5s and go 6 fingers with that, right? 5, 10, 15, 20, 25, 30, 35. Well, that's too many, but 30. So we can count up like this. 5, 10, 15, 20, 25, 30. They list out 6 numbers that way, and we can find the answer that way. Any other thoughts? How else can we get 6 times 5?
Can you do the half of the multiples of 10? Is that what it is?
Mm-hmm. So I'm going to change my 5 into 10, half of 10. Okay. Commutative property or associative property, whatever you want to call it, or commutative property, actually, has me, I can switch that around. And I can say, I can find out 6 times 10 times a half. Okay. I was going to go less formal on this part of the class. Let me go back. Okay. So what we do is 6 times 10, 60. Half of 60 is equal to 30. Okay. So that's how we do it on this one. Any questions on that approach? Okay, so here's another one just for fun. because we like having fun with these things, huh? Let's do, we can even expand it to like anything. We can do 220 times 5. Okay. If we wanted to, you can do, and the 5 will work for anything, not just single digits. Okay, so I could do 220 times 10 is equal to 2200. Then I do half of 2200, and that's equal to 1100. Okay. So the 5's tables trick with the half of 10 times that, times whatever, and the 4's doubling the double, that works for also numbers with any number of digits. Okay. We're going to focus on one digit by one digit. Okay, next one we did was 11's tables. Okay, we're going to try and remember how to do 11 times, we did 6 in the thing, let's do 11 times 7. Okay, what is 11 times 7 according to our trick? Or sorry, no, our mental math strategy. Probably a better way to say it. 11 times 7.
One more than multiplying by 10.
Right. So I take my 7, multiply by 10, and I get 70. 70 plus the one more group of 7 is 77. Excellent. All right, let's take there's the 11's trick that's kind of fun, and you'll see it sometimes. If you have a 2-digit number multiplied by 11, 11 times 32, you take the digits here, the 3 and the 2, and you add them together. And the 5 you put back into the middle of 3 and 2. So the answer is 352. So that's how you can get to 11 squared if you want. So if we're thinking about, I'm going to compare the two methods here, 11 times 11. Okay, so you can do the 11 times 10, 110, and then 110 plus 11 is equal to 121. Or you can take the 11 and add these two numbers together, make 2, and take my 2, put it back in between the 11s to get 121. Okay. So some of you guys might have seen that before, but it's kind of neat. Multiply double digits with 11, but if their digits or sum is less than 10. If you have some that's more than 10, like 11 times 66, you take the 66, add them together. 6 plus 6 is 12. Now the 2 will go in between the 6's, and then the 1 will be added to the first number. Okay. So you have 726. Pretty fun, huh? All right, so that's the 11. Comment, Camille?
Yeah, I've never seen that trick before. It's cool.
Yeah. The next one was the 12's tables. How do I do the 12's? For an example, I want to do, oops, I didn't copy this part down. For the 5's, yeah, for the 5's, half of 10 times, what did we do that? 5's is half of multiplying by 10. Half of multiplying by 10. Okay, the 11's rule in general is times 10 plus 1. Okay. All right, Now we can write down a 12s rule. How can we do like 12 times 6? What do you guys think?
You can do 10 times 6 and then add 6 times 2 to that.
Okay, 10 times 6 is 60. Then I'm going to do 2 times 6 was 12. 60 plus 12 is 72. Good. So that's my answer, 72. This will be the times 10 plus 2 idea. Times 10 plus the double. Okay, so 12s aren't bad. You just times them by 10 and add the double. The next one was the 9s table. Okay, let's try an example. We're going to do 7 times 9. How do we figure this one out? We can use any method. There's a couple of them. Camille had a method.
Do you want me to share or do you want me to let somebody else?
Yeah, you can go ahead and share. Tell us how you found 7 times 9 with your fingers.
Okay, so if you hold your hands up and then you go into your 7th finger, I don't know if it's backwards for you guys, but and
Well,
then you count like 1, 2, 3, 4, 5, 6, and then
oh, actually, it's not. No.
1, and then 3. So it would be 63.
Okay, so that looks good. Looks right for us. Okay, do like 3 times 7, or sorry, 3 times 9.
3
So for
times
another
9.
example,
So
yeah.
if you put your 3rd finger down, it'd be 27. So these are the ones on the other side are the ones placed, or the 10s, and then the ones placed. If
Okay.
that makes sense.
Yeah, do you guys see that?
Like awkward. Sorry.
No, it's hard to do it by yourself. So you can have a couple of students demonstrate that.
Yeah.
Because it's hard to point to your fingers when they're all being used.
Yes.
So,
Oh,
all right. Any questions on that one? You guys got it? It's a pretty handy one. Pun intended, I think. I don't know.
that's so funny.
Yeah. So we have 7 times 9, so we can do it with our fingers. Let's see. We can draw. I'm going to try and draw hands here. Okay, so you have 2 hands held up. Let me move
You're
this
not sharing the iPad.
I'm not? Okay, well then this is just for me. Yeah, I guess let me get my hands drawn first. Whoops. Okay, so one's better than the other one. We'll share here. All right, so with the hands trick, hands or fingers, you're going to count over 7 times 9. So you count over 7 fingers and then put that one down. Okay, so we have 1, 2, 3, 4, 5, 6, 7. Okay. That finger goes down. And I guess I'm going to just draw again here. Oops, I was supposed to put that one down. There's the fingernail. Okay. So we count over 7 fingers. and put it down. Then we're going to display our numbers in this way. We have 1, 2, 3, 4, 5, 6. Okay, so there's 6 of them on that side. And then I have 3, 1, 2, 3 of them on this side. Okay, and so the answer is 63. Okay. So it's kind of a neat thing that nines are related that way. All right, what was the other approach that we talked about in the PowerPoint? Let me remember that one. We'll do 8 times 9. Okay. How did we calculate 8 times 9? Is using the distributive property of multiplication over subtraction is our clue.
You would do 8 times 10 minus 8.
Right. So you're going to do, we're going to multiply it by 10. So let me do that here. And, okay, so the other way is to multiply by 10, or times 10 minus 1. Minus 1 group. Okay, so our 7 times 9, or sorry, our 8 times 9 is equal to 8 times 10 minus 1. So I've exchanged my 9 for that, and we've talked about that already. So 8 times 10, which was 80. And then I did subtraction a group of 9, or a group of 8. So we have 80 minus my group of 8 is 72. So that's how you can get times it by 10 and then subtract one more group of whatever your number is. So if you're multiplying by 9. Okay, so there's that one. The 6 facts that were left, and this
Actually,
is the,
Dr. B,
oh yeah?
I have another trick
For which one?
for nines.
Okay, yeah, tell us.
So whatever the answer is, it will always equal 9 when you add them together. So like in your 7 times 9, 6 plus 3 is 9. Or in 8 times 9 is 72, 7 plus 2 equals 9.
Awesome. Answer always equals 9. Okay, so for example, we can do like 4 times 9. We know that that's 36. We know that 3 plus 6 is 9. Okay. So there's a good way to check your answer or to find it. So all of them, whoops, let me adjust here. Good. So there's 6 facts left. We have 6 times 6, 6 times 7, 6 times 8. We have 7 times 7, 7 times 8, and 8 times 8. Okay. Anybody have an idea how we can calculate 6 times 6? Like derive what the answer would be. So we'll try and get through as many of these as we can before our time ends. 6 times 6, we can break up the 6's into multiplication or addition. What do you guys think?
In my mind, I do like 6 times 5 and then add 6.
Great. So I want to do 6 times 5. So what I'm really doing is I'm changing the 6 into 5 times 1, 5 plus 1. Okay, that's going to be 6 times 5 plus 6 times 1, which is the distributive property. I'm distributing the 6 to the 5 and to the 1. Okay? That's 30 plus 6 is equal to 36. Okay? That's the math way. So the quick way is to just say, okay, she calculated 6 times 5 is 30, and then did 30 plus 6, I think. Okay. All right, the second fact is 6 times 7. How can we calculate 6 times 7?
It's 36 plus 6.
Great. Using the deductive thinking, 6 times 6 plus 1 is equal to 6 times 6 plus 6 times 1, which gives 36 plus 6. Now, 6 times 6, the number 1 here, is actually a square number, perfect square numbers, so a squaring fact. And so a lot of times kids can memorize the doubles in this, from addition and the squaring from multiplication pretty quickly through chance or whatever, saying it to themselves. Okay? Especially since the answer has one of the digits in the problem, so that really helps too. And then we get 42. Good. So again, the distributive property is used. Next one is 6 times 8. What do you guys think about that one? How could you memorize that, or how can you derive it?
I used to use the chant like 6 times 8 is 48.
Good. That's what I do. Okay. We can also do 6 times. We can split up our 8 into 4 times 2 into these factors. Now notice that I'm not going to use the distributive property here because these are all multiplication and not any additions in there or subtraction. Okay, so I can't distribute the 6 to the 4. This is what students like to do. They like to do this. But it doesn't work because I'm doing all multiplication. Okay. So what I can do is use the associative property and associate the 6 and the 4 together. And then I have a double that I can do. Okay. So 6 times 8 is 48. Okay, 2 more. Wait, so 1, 2, 3. Yeah, 3 more. Okay, 7 times 7. You could do like 7 times 5 plus 2. Okay. 7 times 5 plus 7 times 2. 35 plus 14 is 49. There's one way of doing that one. Number 5, 7 times 8. For some reason, I also memorized this. 7 times 8 is 56. I don't know why, but that one always stuck with me. But you can also do, make it a double. Let's see. You can do 7 times 4 times 2. So you can do that, and you guys can finish that out. Or you can do like 8 times 7 is equal to 8 times 5 plus 2. Okay. It's 8 times 5 plus 8 times 2. You can do it like that. So there's nice ways of that one. Let me see here. And then we have number 6. Let me finish this one out. 7 times 4 times 2. And 8 times 2 equals 56. 8 times 5 is 40 plus 16 equals 56. Okay, that was easy. And then the last one is 8 times 8. Any thoughts on 8 times 8? We still have a minute.
So I was just going to chime in with, oh, can you hear me?
Yeah.
Okay, I was just going to chime in with the chants. So I was actually homeschooled, and my cute mom taught me the multiplication facts, and she came up with little chants for some of them. So like for the 6 times 8, it was 6 times 8 is 48. Multiplying is so great. And 8 times 8 is 64. Shut your mouth and say no more. I don't know why it stuck, but my mom's cute, and there you go.
Good. Okay. Now, if you tell students to do that, that might be kind of harsh. But your mom, you and your mom have this understanding. Yeah, 8 times 8 is 48. Multiplying is so great. Is that what you said?
Yeah.
Okay, I like that one's a little bit more positive. 8 times 8. Yeah, there could be a lot of them because the 8s can be broken down in a lot of ways.
With the 8s, I usually just do on the 9s on my fingers and then minus 1. Like,
Okay.
so it's 8 times 7 and 8 times
8 times
8. I just do 9 and then minus the 7 or minus the 8.
8 times 9 minus 1.
Yep.
So that's equal to 8 times 9 minus 8 times 1. 72 minus 8 equal to 64. Okay, there's a good one. All right, that's all we have for today. So we're a couple minutes over, but thank you for contributing and everything. I appreciate that so much. Enjoy multiplication facts from this homework. The homework's not too long, I don't think. So some good readings and stuff going on.
Thank you. Have a good weekend.
Welcome. Have a good weekend.
Oh, I had a question on the 3rd. Do we have school?
No, that's a good question. There's no school on Friday, and I was going to talk about that next on Monday.
Okay, awesome.
Yeah.
Thank you. Have a good one.
You're welcome.
If you have a second, Dr. B, I just had a quick question about the test.
Okay, so were you the one who originally asked? There's like one other person.
It was me, Dr. B. I can wait.
Okay.
I'm actually trying to find, I split up the test in different notebook pages. So I'm looking for those right now. And she
Okay.
can go first.
All right. So I'm going to go, since we're talking about tests, I'm going to create 2 breakout rooms, and I'll have Ariana can have you join one. And so pick a breakout room there, and I'll stop the recording as well.